Right, and now we have some reactions for our aldehydes. First off, we're going to start out with reduction and oxidation reactions for aldehydes. Now, these are actually very familiar. They should be because this first one, reduction, is just the opposite of a reaction we had last chapter. We learned last chapter that if we had a primary alcohol and we oxidized it, it would turn into an aldehyde. So this ethyl alcohol molecule turned into an acetaldehyde or ethanal molecule. So this chapter, we're just going to start out with an aldehyde, like this one, and we're going to reduce it, which is the opposite of that first reaction, and then that means you just take that double bond and you turn it into a single bond, and it's a hydroxyl group now. So I had a butyraldehyde or a butanal, and I turned it into a butyl alcohol or a butanol. And this is where things get really confusing, and it's kind of distracting going back and forth from one kind of name to another. Because if I call this ethanol, and it is ethanol with that OL ending, and then I call this one ethanal over here, that sounds pretty much the same, and it can be misleading sometimes. So there's a reason why people still use those common names for aldehydes, where I'd call this acetaldehyde instead of my ethanal name, because it's just easier to differentiate between the ethanol and the ethanal now. That acetaldehyde sounds nothing like ethanol, so it's a little easier to remember which thing's which. Right? And then on this bottom example, right, this is a butanal, excuse me, I'm having a hard time writing down there. So this is a butanal, and this is a butanol. Right? One thing that would be different in this case is I have to tell you it's a 1-butanol, whereas I didn't have to tell you it was a 1-butanal. So you just got to be careful. But that's another reason why I might call this one on the left a butyraldehyde instead of butanal, because it's just a little bit more different. It's easier to differentiate which one's which. I don't have to really hyper enunciate that last syllable to make sure you know what I'm talking about. So this reduction reaction is just the opposite of the oxidation reaction for alcohols last chapter. Instead of going from a hydroxyl group to a double bond oxygen, you go from a double bond oxygen to a hydroxyl group. Sometimes I will write this reaction a little bit funny. So I'm going to insert a page here. Sometimes this reaction will be written like this. So you're going to start with, say it's a propanal, right, or a propionaldehyde, whichever thing you want to call it. And then I will give you this other reactant. Excuse me, this is being a little squirrely on me. The board's not wanting to work right now. But maybe I'll give you that propanal, and then I'll say that you have hydrogen, and I'll give you this platinum catalyst. That should be a capital P. Right? So I put that T2 ahead to make it look like a capital. But this actually was one of our very first reactions from a long, long time ago, and we were talking about double bonds, right? But we usually were talking about double bonds between carbons. But this is actually the same thing. This is an addition of a hydrogen across the double bond. So the end result is the same as our previous slide. Instead of having a double bond to oxygen, I'm going to break that double bond, and I'm going to add a hydrogen to both sides. So now I have a hydroxyl group instead of that double bond to oxygen, that carbonyl group from before. So it's actually the same as an addition from our alkene reactions. It was called a hydration reaction before. So I just took this double bond and made it a single bond by breaking it and adding a hydrogen to both sides. Over here, I have no hydrogen on the oxygen, but I have one hydrogen on the carbon. And then on the right, I will have two hydrogens on the carbon and the one hydrogen that's there in the hydroxyl group.